I will be discussing with you on how to solve problems involving the first condition of equilibrium. When we say equilibrium, we are talking about how to balance an object. For the first condition of equilibrium, it is otherwise known as our translational equilibrium. Now, it states that for a body, any object, to be in equilibrium or in balance, the resulting force acting on the body in both x and y axis must be equals to 0. Looking at the formula, you can determine that there are two involved formulas in solving translational equilibrium. First is that the summation, when we say summation, all of the forces, F is force, in the x-axis should always be equals to 0 in order for an object to be in balance. All the summation or all the forces acting in the y-axis also should be equals to 0 in order for the object to be in balance. So when we are talking about all the forces in x and y, we are talking about three definite forces involved for an object to be in equilibrium. The first force is the gravitational force. It has a constant value due to acceleration of gravity, which is negative 9.8 meter per second squared. That is your gravitational force. Another force involved is the tension force, which is symbolized by big letter T. Another force involved in our problem solving is the weight. So these are the three forces that can be found to be present when a body is in equilibrium. So the unit of forces, we have two, newtons and dynes. Newton is otherwise known as your kilogram meter per second squared. And then dynes is otherwise known as your gram centimeter per second squared. We have a sample problem here. Our first problem is a load weighing 10 newtons is hung on a tree. Find the tension on the rope that holds the load. So in the problem, this is the illustration. So a 10 Newton load is hung on a tree. So if you're going to look at the illustration, there is an upward force, which is our tension force, because it lifts the load, which is 10 newtons. And then there is a downward force here, which is represented by the weight, which is your downward force. It is the pull of gravity towards the center of the earth of this load. If you are going to look at the illustration here, skeletal illustration, this is the y-axis and this is the x-axis. So in the y-axis, we can see forces acting on it. The tension force or the upward force, and the weight, which is the downward force. So in the problem, we need to find the tension of the rope that holds the load. So it is represented by T, and it is that which is unknown. The weight of the load is given, which is 10 newtons. So note that there are two forces acting on the hanged load, the tension force and the weight. Note that the weight is always negative because it is a downward force. Both forces are acting in x or y axis. Okay, looking at the diagram, there are no force acting on the x axis. It is only on the y axis. So let us provide the given in the problem. Given, there are three forces acting on the load. First is the weight, which is your negative 10 Newton. Okay? And then the tension force, is another. So looking at the given, there is no force acting on the tension in the x-axis, so 0. And there is no force acting on the weight on the x-axis. This is the x-axis, so it is 0. What we have in the illustration or the diagram is tension y, this is your tension y, is equals to Ty because it is our unknown. Wy, or your weight, which is a downward force, has a value of negative 10 newtons. Applying the formula of translational equilibrium, we have this. Summation of all the forces in the x-axis is equals to 0. So under this summation, we have your two forces, the Tx plus Wx, I should say. So, summation of all the forces in the x-axis. Lahat ng forces na nandito sa x-axis. Okay? Pagsamasamahin natin, kasi summation, sum. So, plus siya. Tx plus Wx is equals to 0. So, ano ang value ng Tx? Value of Tx here is 0. And the value of our Wx is 0. So, 0 plus 0 is equals to 0. So, balance siya. Walang force. Okay. Next, we proceed to summation of all the forces acting on the y-axis is equals to 0. So, what are the forces acting on the y-axis? Ito siya. So, dalawa. So, we have Ty plus Wy is equals to 0. Kasi there are only two forces. Kaya dalawa lang ang nilagay natin dito. Okay? So, what is the value of Ty? It is Ty because it is our unknown. Plus, what is the value of Wy? Negative 10 Newton. So, we place that is equals to 0. In order to solve for Ty or the tension force applied in the load, what we do is to transfer negative 10 newtons to the other side. And when we do transfer, it is automatic that we change the negative sign into positive sign. So, positive 10 newtons or 10 newtons. So, the tension force exerted by the rope to carry the load is 10 newtons also. So, here. So, in order for this load to be in a balanced state, the rope should exert 10 Newton tension force in order for it to be in a balanced state. Going further, we have another problem here. Problem number 2. Okay. A load with a mass of 3.8 kilogram is hung on a tree. Find the tension in the rope that holds the load. Okay. If you're going to have the diagram, again, there are two forces involved in our problem. The tension force and the weight of the load. So, since there are two forces acting on this, again, the given is the tension force is our unknown. And the weight of the load is 3.8 kilograms. What is given here is mass. 3.8 kilogram is our mass. It is not yet weight. So in order to solve for the value of 3.8 kilograms to become force, we need to use the formula weight is equals to mass times gravity. So weight is equals to 3.8 kilograms, which is given in the problem. Let us multiply this with the constant value of acceleration due to gravity, which is negative 9.8 meter per second squared. As I have said a while back, negative 9.8 meter per second squared is constant. So in solving, weight is equals to, multiply the two, negative 37.24 kilogram meter per second squared, or negative 32.24 newtons. After solving for the weight, we are now ready to solve for the unknown. So again, all the forces acting on the x-axis is 0. So it is automatic that this is 0. Next, all the forces acting on the y-axis should be equals to 0. So we have two forces involved here. So Ty is our unknown plus Wy, which is our negative 37.24 newtons, is equals to 0. So the tension that should be present to exert a pulling force to our load should be 37.24 newtons, or 37.24 kilogram meter per second squared. Okay? In order for an object to be in a balanced state.